Hi, in this video, let's try to implement Retrieval Augmented Generation or RAG using LangChain and Llama3. So first, let us briefly try to understand what exactly is Retrieval Augmented Generation. If we have a large language model that is already trained, we'll be basically doing inference on it as we are giving the LLM some prompts and getting responses. However, what if we want the LLM to process something based on some data that it is not trained on? This process or a framework that will help in this regard is called Retrieval Augmented Generation or RAG. So it can basically combine some external data along with the capabilities of an already existing LLM, such that you don't have to retrain the LLM, but still you can use it to make processing or analysis on some data which you are providing. So you as a user, you will be doing a bunch of analysis or calculations on database that exists with you, but all the calculations will be done using a already trained LLM, maybe GPT or cloud, etc. And you can get that information back, or you can get the analysis from the LLM back on the database which is private to you. And this is very important because many companies are trying to create chatbots or agents, and these agents should ideally be trained on their data that is private to them. And it's sometimes very expensive to train a LLM from scratch, right? It takes weeks, it takes probably millions of dollars to train an LLM from scratch. So imagine you don't want to train an LLM, but you want to use an already trained LLM, but in the training data, your information or your company's information or whatever information is there in your database was not included. Then RAG is a technique which will allow you to incorporate the information from that document. So it's like extending the capabilities of LLM as you see here, and without the need for retraining the model. And many companies, including Amazon, are trying to do this because Amazon, for example, on a daily basis, they are getting millions of queries or questions from the users or customers, and it's very expensive for them to maintain human customer service people. And what they're trying to do is to create chatbots or AI agents that can respond to the customers in a very efficient way. And these AI agents should know all the internal stuff or product details or things that are concerning only to Amazon. And maybe an LLM that is trained using internet data will not know these things. So that's RAG is what will help on this. So there is a retrieval component in RAG. If you are building an AI system for an educational company, you could have a CBSE class 7 textbook, the PDF of these text chapters as the retrieval component. This might be part of your database, and the large language model or the language generation model like GPT-4 or GPT 3.5, that will be the LLM. So these are the two parts of RAG. And in this particular video, we'll be trying to use Llama3, and Llama3 is the largest language model so far released by Meta. It's open source. There are predominantly two models, one with 8 billion parameters and one with 70 billion parameters. Llama3 was actually released only very recently. Llama 2 was already there, and apparently another new version of Llama 3 is under development with 400 billion parameters, which may be really, really powerful. And we will need three things to build the application that we are building today. One is llamaindex API, groq API, and Google Colab. Let's look at what is llamaindex and what is groq. So llamaindex is a platform that helps us manage data for processing by LLMs like LLMs or chatbots. So it has a very nice way of organizing or querying or indexing data. And you must have already probably heard of llamaindex, but not very sure what exactly it is. I'll also quickly show the llamaindex website and where to get the llamaindex API from. And groq it has a language processing unit. You can think of groq like a cloud-based solution. So if you want to run Llama 3, you won't be able to host it yourself and run it yourself. You would rather use some cloud-based service who's running Llama 3 for you. You may be paying them, or it may be free depending on their business model. But basically, the value proposition of groq is that they have something called as LPU, language processing unit. It's different from GPU. GPU is optimized for both training and inference. So if you have a large language model, GPU is good for training the large language model on internet data or whatever data you are providing, and also for inferencing. Inferencing meaning you'll be giving prompt and you'll be getting responses. But in your case, you are not training ChatGPT, right? You are just inferencing from it. You are inferencing from an already trained GPT, or you are not training Cloud or any other LLM. So you just want inferencing. So language processing unit, it's optimized for inferencing, and this improves the speed, it reduces the cost, and also improves the energy efficiency. So that is what groq is. So we'll be using Llama 3 through groq API. So that's why we need groq API, and llamaindex API we need for organizing the data, indexing it, querying it. So before we go into the coding, I just want to show you the llamaindex and groq. So let's go to the website. This is the llamaindex website. To get the API corresponding to this, you will have to go to cloud.llamaindex.ai and click on API key. And here you can click here to generate a new key. And once it's generated, you will see that here you can copy it and you will have to use it. So this is the first API key that you will need. The second one is from groq Cloud. I'll post the link to both of these in the description. And you can go to console.groq.com/keys. You will have to, of course, create an account. And then in the API keys, you can create an API key. I have already created one. I just need to copy it. So these are the two things we need. And today we'll be coding in Google Colab. So I'll open that and let's go through the code. Okay, let's go through the code. So this is the Google Colab notebook. I'll be sharing the link to the notebook in the description. So first we are installing the required packages. We have a package for vector embedding, document processing, Q&A related tasks. So, and also for LangChain, because we are using that. So first this pip install will install the packages, and after that we'll be importing the packages. This will not take too much time, probably 2 minutes max, if I remember correctly, because I had run the code once before. And as this is installing, I'll go through this part. So there is a piece of code which I am not displaying here because it displays my groq API key, but the code looks like this. So what you can do is, once you generate the groq API key, just uncomment this part of the code and insert your API key here. And after that, we'll be importing these libraries. The libraries are for loading the documents, the vector embedding, and interacting with the ML models for Q&A, etc. And what we are going to do is we'll be converting the document into a markdown format after parsing. So we'll get to that. So I'll pause the video and come back once this installation is done. The execution of the code has finished. It took almost 4.5 minutes. So I'll just clear this output just to make it look good. So this part of the code I'm running to initialize the groq API key. So that is done. I don't have to run this. Then we are importing the necessary libraries as I just explained. This should also not take any time. Okay, so now we come to the document parsing. So in document parsing, what we are doing is, so parsing means if we have a sentence in a document, we are kind of arranging it into meaningful chunks which can be interpreted and understood easily. And we are also providing an instruction. The document provided document is a research on India education. It contains many graphs and tables. Try to be precise while answering the questions. So the goal here is we would like to perform retrieval augmented generation using Llama3 and using LangChain on a particular document. So I have a PDF document which is a research on Indian education landscape, and it has a lot of graphs and tables. Actually, let me show you the document once. So this is the document. It has a lot of interesting facts, distribution of schools by management, private, government, schools, etc. Then it has a list of number of teachers, how it has increased from last year to this year, etc. Let me just show that. How do I... Yeah, I think this is better. So it has some of these facts and tables. You can see the number of teachers, 9.5 million. So there are a lot of numbers. There are graphs that are like figures, and we are hoping that the LLM can read all of this, and if we are asking some information specifically from this document, it should be able to answer. So what document parser does is it will convert the information within this into meaningful chunks that are interpretable. So let's go back to the code. So first, this is the instruction for Llama parse. So we need the Llama Cloud API in this part basically. So let me run this and run this. So here what I'm running is a copy of this part of the code, and the API key for Llama Cloud is supposed to be inserted here. So I don't have to run this. I'll just comment this part of the code, because what I ran here in this hidden part of the code is exactly this. And the next thing is, since I'm using Google Colab, I'll just upload the document here. So click this file icon, new folder. I'll just create a folder called data, and here click to upload, and I'll upload the PDF document here. And once the upload finished, I'll copy the path and paste it here. So this is an asynchronous PDF document parsing. Once we print it, you will understand. So click this, you will see the PDF document here. Click copy path, and now the path should be copied. It's the same path, I guess, but just paste it here. Okay, so that is done. Just run the code. So parsing is done, and now we are just fetching the parse document and displaying the parse document as a markdown file. So this is how it looks like. You can see the markdown format. In the actual document, it was looking like this, right? So in this way in which the information is stored in the PDF, we have to convert it into a markdown file, and it's much more easily readable. So that's what it is doing here, and information is not lost. So if you look at the figure 1, let's go to figure 1. Figure 1 has distribution of schools by management, 5%, 23%, 3%, 69%. I guess yeah, I guess some information is lost. So government aided, private is there, and private others, this 3% I am not able to see. Also private aided, private unaided is 32%, but actually it's 23%. Okay, distribution of enrolled children, distribution of schools, distribution of enrolled children. Yeah, see, there is a mistake here actually. This is not 32%, this is 23%. I don't know how the document parser made that mistake. As you can see here, let me zoom in. Private unaided is 23%, and private, this is the distribution of school by management, and this is distribution of enrolled children by management. This is 32%. That is correct over here, but the previous, this mistake is there. So I don't know how many such mistakes can happen in the document parsing, but hopefully it should be correct. We'll see that in the Q&A part. So this is the markdown document, and then we are saving this parsed document in markdown format for later use. So that is this part of the code. I just ran that. Now next thing is, you might know that for large language models to process any kind of information, it would like the information in the form of vector embeddings, and these vector embeddings have it's essentially converting a document or any language into tokens. So you divide the instruction or prompt or the document into chunks or tokens, and then these tokens are converted into vectors in an n-dimensional space. So LLMs or computers cannot process English language words, it needs numbers. So the process of vector embedding is converting the English words into mathematical numbers, and specifically in the case of vector embedding, we are converting these tokens in English or special characters into, or numbers, or when I say numbers, I mean these kinds of numbers, into vector format. And the vectors in this n-dimensional space has meaning. So it's not random vector embedding, it's embedding based on a certain rule, and we'll be using a certain way of embedding. So first we are loading the saved markdown document. So we had saved the document, first we load that, and since the markdown document contains the entire information about this PDF document, we'll split it into smaller chunks. Chunk size is defined to be 2048, and we define an overlap between different chunks. And here we are printing the length of the docs. So I think this should depend on the chunk size also. So if I make this 1024, it became almost double, but if it is 2048, it's almost half of that. And if I do this, it will again become almost half. So that's how it works. So I will split it into 2048, and here to verify that we have actually split the document, we are just printing the first chunk of the split. So this is the first chunk of the split, and it's actually working. So we have now split the markdown document into a certain format. All right. So now what we are doing is we are initializing the vector embedding, and we'll be using this function called fast embeddings. So the text within these chunks will be now converted into vectors. So first let's initialize. Okay, this is initialized, and now we have quadrant vector store, and it has the embeddings of the document. So basically what we are doing is this docs which you see here, this was the markdown split into smaller chunks. We are passing that, and once we run this, we have the, it should not take too much time. I'll pause the video and I'll come back. I don't think it should take more than a few seconds. Let's see. Okay, so this part is finished. So essentially what we are doing is the chunks which we split the document into, it is the words within those are, or the tokens within those are stored as vectors in this quadrant vector store. So let me go up. So we define the chunk size to be 2048, and there is overlap between the chunks. And here we are displaying the first chunk. So the first chunk looks like this. And now here we converted that into vector in this vector store. And now what we are doing is we will perform a similarity search on the vector store. So this is the query, and then here we are fetching the similar documents, and let us print the top similar documents. So what we did here is, this was the query. So why is the education system failing in India? Maybe I should change the query to something else. How many teachers, or I can ask based on government aided schools are there. So let this be the query. And when I run this, you can see that the fetched part of the document ordered in terms of similarity score. So this is similarity score 0.77, 0.73, etc. So this is in the descending order of similarity score. You can see that it's printing, and the first one is most relevant to the query that we asked. Maybe let me try asking something from here. I'm just curious to see how the okay, let me ask something about teacher salary. What is the teacher salary for private schools? So this is the new query. And if we print the similar documents, yeah, you see, it's printing the section of existing teachers. I think this is not probably the most similar. I would say this is the most similar, but I guess the similarity score depends on the depends on how the vector store is storing it. So it's not as simple as mapping things from what you see in the query and what you see in this similarity, the document which is printed. But anyways, retrieving document using quadrant as retriever and printing the retrieved document. So let's do that. So here we are printing the retrieved documents, and let's go back to the ranking. Now we have to use this flash rank re-rank compressor. And what we are doing here is the retrieved documents are re-ranked. So we'll be performing that re-ranking. So this piece of code does that. And the length of the re-ranked documents is 3. I guess that is, I just want to see if the re-ranked document, never mind. I was just curious about something, and now let's print the re-ranked document. So the length of the re-rank document was 3, and you can see that there are 3 documents that are displayed here. And there is a score which is in the descending order, so the ranking is accordingly. Now what we can do is we can use so far we have not involved the large language model anywhere. We just used the document parser. We parsed the document, we converted it into a markdown format, we split it into chunks, then we converted that into vector embeddings, and then we found similarity score based on a query, which documents are most similar to this query. So we created a similarity score, we performed re-ranking, but we are yet to do the actual querying using the large language model. So that we'll be doing here. So we'll be using the groq API to run the Llama3. There will be some limitations here because I'm using the free version of the groq API. So I guess there is limitations with respect to the token size, and maybe some other limitations. I have not checked it very much detail, but I think the paid version of the groq has much more capabilities. But for our purposes, this is more than enough. And initially here we'll define a prompt template, use the following pieces of information to answer the user's question. If you don't know the answer, just say that you don't know. Don't try to make up an answer. The reason why this is written is that our document is something with a lot of actual information and research. It's very factual. It's India education fact. So there is not much scope for coming up with creative answers. This is not about that. This is purely about learning information and displaying it in a format that is useful for us. So that's why we don't want the LLM to make up some answer or be too creative, and answer the question, provide additional helpful info, and be succinct. So let's run this. So this defines the prompt template, and context and question is defined here. Now initialize the retrieval QA chain, and this is the new prompt. This will now, what it is going to do is, in our fact sheet there were some information, and the kind of way in which the similar documents are displayed is in the format of how it was exactly present in the document, right? Like if you look at these sentences or these parts, this is exactly how things appear in the document. But this is not a very user-friendly format. We want some intelligence to be used in or intelligence to be deployed in the way in which document is analyzed. So that's why we need the large language model. And when we display, let me go down. Let me print the response, then we'll see what the LLM is saying. So the question was, why is the education system in India failing or succeeding? Does not matter. We can ask whatever. Facing challenges, but it's not explicitly stated that it's failing. See, we had asked the LLM to be very specific, and the document that we had provided, it was not about failure or anything. It was just talking about probably challenges and just in an unbiased way mentioning certain facts. So in no way the document is suggestive that the education system is failing, but here are the areas of concern. Average scores of students, 36 million children are out of school. Sustainable development goal declined. The score of SDG declined, etc. Additional information. So we had, you remember in the query we had asked two things. One was to be precise and also provide any additional info over here. So the response has exactly done that. Let me ask something more factual than something like this. Maybe I can ask, how many teachers are there in total by 2022? Are there in 2022? And print the response. There are 9.5 million teachers. Number of teachers in India decreased by 1.95%. This is actually interesting because I don't know. So yes, that is true. Number of teachers have decreased from 9.78 to 9.51. But where is this 1.95% coming from? I am very curious because I don't know if it Okay, this is mentioned here in the document. Okay, so this is very good. I thought I thought ChatGPT might have calculate. I mean, GPT might have calculated this or something, but sorry, Llama 3 would have calculated this or something, but that's not what happened. I thought this 1.9. I had not seen this 1.95 number here. It's over here, but this is interesting. I can ask maybe some mathematical question. Hmm. How about what is the average? So here this is about the salary in government and private sector. I think this number is the average salary of all teachers. I want to ask something that is not there in the document. That is something that we can calculate based on the document. Okay, maybe I can ask how much is government school primary teacher paid more compared to private school teacher? Maybe we can ask that. Okay, so how much is government school teacher paid more compared to private school teachers in primary school? Let's see how well the response is going to come. The difference is something like 16,701. Sorry, I don't know if my math is correct. Whatever, we'll see once the response come. Oh wow, my math skills are not bad. So the government school teachers in primary are paid approximately this much. I hope this number is not explicitly mentioned anywhere in the document. 101. I hope it's not mentioned anywhere. Maybe I'll try with a comma. Okay, so actually this was a calculation which was very accurately done based on the info in this table. This is very, very good. So I hope now it's very clear for you the value proposition here. We can of value proposition of retrieval augmented generation. I won't be doing any more prompting, but you can provide a document which the LLM would not have been trained on, and you can ask specific information with respect to that document. And because the LLM is there, it can also perform tasks like this, what you just saw. It can analyze the data from the document. It can provide responses based on that, and surprisingly, it can also be very accurate. The only thing which I got surprised was the mistake that was made in the document parsing. I'm not entirely certain why that happened. Like this one, this is not 32% as you see in the document. That is 23%. So feel free to comment if you can, if you understand why that's happening. Maybe it's something simple, but I'm very curious to know. But that's pretty much it. I'll share the code in the description. Feel free to run experiment and share with us if you have observed something very interesting. So thank you so much and see you in the next video.